Fourth grade ELA, text 6, illustration study craft. The essential question: how does an illustrator make decisions to interest readers? Our goal for today is to notice and understand characteristics of an informational book. Remember reading Giant Squid? One thing we learned was that giant squid have the biggest eyes of any animal. This new book, Eye to Eye, How Animals See the World by Steve Jenkins, provides information about the eyes of many kinds of animals. Let's look on the book cover for a clue about some of the things we will read about. Look at these eyes. Read aloud the text on the back cover. Did you know the eyes of the colossal squid are each the size of a basketball? The butterfly can see colors that are invisible to us. The tutora, a kind of lizard, has a third eye on the top of his head. Find out all about animal eyes in the stunning new book by the award-winning author Steve Jenkins. Alright, most animals rely on their vision more than any other sense to find out what is going on around them. For these creatures, the eyes are the most important link to the world. Being able to see help animals communicate, find food, avoid predators, or locate a mate. Animals are found in just about every habitat on Earth, from deep oceans to snow-covered mountains, and they have developed extraordinary diverse eyes and ways of using them. Some creatures can do no more than tell days from night, while others can see colors invisible to humans, spot prey at a great distance, or find their way in what appears to use to be total darkness. So turn the page and meet animals with more than 100 eyeballs, eyes that can look in two directions at the same time, eyeballs the size of a basketball, and many more. So the red-crowned Amazon parrot has excellent color vision, useful for the finding of the fruit and flowers it feeds. The jumping stick insect, this one right here, is actually a kind of grasshopper. Its protruding eyes allow it to see in many directions at once. Diverse is an important word on this page. It means different from each other. So the first eyes, this is a heading, so we need to be reading that. There could be no life on Earth without the sun. Since the planet's earliest days, the sun has warmed it and bathed it in light. The first forms of life, tiny organisms, adrift in the oceans. Depending on the heat and light, like modern-day plants, they absorbed sunlight and used it to produce their food. But for more than 3 billion years, all living things were blind. They sensed only what they could touch, taste, or feel. Then about 600 million years ago, a few animals, the ancestor of modern jellyfish and sponges, acquired an important new ability. They had become the first animals that could see. Their eyes were just simple clusters of light. Light-sensitive cells, but they gave their animals a big advantage. The shadow of a predator could send them moving to safety, while creatures that couldn't see at all were more likely to be eaten. Millions of years passed, and eyes continue to evolve. Highly developed visual systems appeared, many that could discern colors or produce sharp images. Eyes and ways of seeing became more and more diverse. Today there were dozens of different animal eyes, but most are variations of 4 basic designs. So we have the simplest eye is a cluster of light-sensitive cells known as an eye spot. This eye can't form images, but it does detect light. Some worms have eye spots, as do starfish, which have an eye spot at the tip of its leg. So this is the second one, a pinhole eye. A giant clam has thousands of pinhole eyes, and each a small opening focuses light as it enters the eye. Pinhole eyes can form detailed images. They don't emit much light. However, so the images are dimmer than those created by a compound or camera eye. This is the third type of eye. Dragonflies and other arthropods have compound eyes. Each is composed of hundreds of thousands of individual lenses or facets. In some animals, the facets form separate images. In others, they combine to create a single picture. And then the camera eye. The camera eye employs a lens to focus light on the sensitive surface of a retina. It is found in all birds, amphibians, reptiles, and mammals, including humans. Octopuses, box jellyfish, and a few other animals also have camera eyes. So your eyes are camera eyes. They work the same way as the eyes of the owl in the illustration. How does the owl's eye look like your eye? Okay, and then let's talk about this. The author organized these pages in two big categories. The first category is about the first eyes, and the second category is about a different type of eyes. How did the author organize the information about different kinds of eyes? Okay, the author organized the info about different kinds of eyes in 4 smaller categories, each about different kind of eyes. When a category is split up into smaller categories, each of the smaller category is a subcategory. Okay, move away from the light. The eye spots of the sea slug can't detect light, but they can't form images or perceive the slug's own brilliant colors. This kind of eye has been around for hundreds of millions of years. So the color of the headings on pages. So let's look. There's different colors for these headings. What is the purpose of these headings? How do they help you understand and follow the information in the book? A pinhole eye. Animals have, much like the nautilus, have been around for 500 million years. Its pinhole eyes can discern objects in other animals, but only if they are large or very close. These eyes have no lens, so water flows in and out of the nautilus pupils. Scallop. How many eyes? The Atlantic Bay scallop is also known as the blue eye scallop, and 2 rows of blue eyeballs are sensitive to movement as well as light, allowing the scallop to snap shut when danger threatens. The number of eyes can vary. One scallop has found to have 111 eyeballs. The biggest eye. The eyes of the colossus squid are each the size of a basketball, the largest of any animal. The deep ocean waters where the squid lives are completely dark. Like its huge eyes, however, can detect the faint glow of tiny bioluminescent creatures. When they are disturbed by an approaching sperm whale, the squid's arch enemy. So the colossal squid's eyes are very similar to those of the giant squid. Colossal squid live in the dark ocean too. The moving target, we're going to skip that part. Okay. So seeing the invisible. The Blue Mountain I'm going to skip that part. If looks could kill, the jumping spider is a hunter, and it relies on its 8 eyes to find and kill its prey. It has 2 pairs of eyes on each side of its head, not visible in this view, that detect movement. A wide-set pair of eyes on the front of its head provides depth perception, and the 2 large eyes in the middle of its face form detailed images, giving it the keenest vision of any spider. So what are you noticing about the illustrations? Why do you think Steve Jenkins shows 2 pictures for each animal? What do the pictures help you understand? So there's a picture of that, and then there's the picture of the close-up spider and their eyes. I'm going to skip this, and I'm going to go over to here. Things are looking up. A young halibut, like most fish, has an eye on each side of its body. As it gets older, however, one eye migrates over the top of the first fish's head. Eventually, both eyes end up on the same side. The halibut spends most of its adult life lying on its side on the bottom of the ocean, and this arrangement means that both eyes will be directed upward, away from the sea floor. Over, under, sideways, down. That is another heading. Sorry. The panther chameleon can move and focus its eyes independently. It can look in 2 directions at once, watching for prey and danger at the same time. Can you imagine being able to look in 2 directions at one time that a chameleon can? I'm going to skip those parts. Alright, and then I'm going to go to this one. Rainbow vision. The eyes of the mantle shrimp are the most highly developed in the animal kingdom. They are much more sensitive to color than our own eyes, and they can detect light that is invisible to most other creatures. These eyes help the mantis shrimp find prey and avoid danger in the colorful coral reef habitat where it lives. Sharp-eyed hunter. The Eurasian buzzard has the sharpest eyesight of any animal. Its vision is 8 times more accurate than ours, keen enough to home in on a rabbit 2 miles. So did you know animals' eyes could look so different and work in so many different ways? Okay. And then, as you can tell that there are bolded words right here. You can see these words that are bolded. Why are they bolded? Bolded. Because in the back, the author provided glossaries. A glossary is to give you definitions of words that you may not know. And it won't really tell you in the text. This is very much found in nonfiction text, okay? As well as different diagrams such as this. This is the evolution of the eyes. Okay? It shows you the eye spot. They show you the eye cup, pinhole, primitive lens eyes, and the camera eye. This is a diagram. Usually in nonfiction text we have a diagram. So our goal was to notice and understand characteristics of an informational book.